Good evening, ladies and gentlemen. I have with big pleasure to present you my research achievements. I am from Lincoln University. My name is Gawel Solosky. I work on hydrogen production by dark fermentation, and I work on many aspects of dark fermentation as modeling, as providing, optimizing pretreatment, substrate, and all process that going to industry. Because dark fermentation is the process of converting of organic matter anaerobically to form hydrogen. This is the aim of this process of prepare of the process is forming bacteria such that will block the next stage of anaerobic digestion, that is consecutive to dark fermentation, which is methane fermentation that uses this hydrogen and organic acids producing in this phase of dark fermentation to produce methane. And the aspect is that we can prepare, but the trouble is to keep this bacteria stable on hydrogen production and quite efficient. The method is of wet treatment, so preparing to the sporage forms of bacteria are very various: aeration, heat shocking, acidic wet treatment, oxide recruitment, some agent like chloroform, all kinds of uses that can stress bacteria and force them to form a sporage form. Because high hydrogen for production goes in the case when bacteria crosses from sporage form to the normal form of the bacteria. The sporage form bacteria are mainly mostly by Clostridium. Sometimes are from Enterobacter, but which are more fragile and more as facile. The strict bacteria are so the mostly producing hydrogen are Clostridium type, and these forms quite much sporage, so the form that produce mostly hydrogen. This is the difficulties is to keep, because if we one time pretreated, the next generation, which occurring every 3 days, will disappear and don't have. There are two possibilities. Always place bacteria all the time next fresh bacteria pretreated, or already in the vessel we can make pretreatment different. But if we make this pretreatment on the one layer bacteria at the same time, the bacteria will start to accustom. So the bacteria after some time will stop. The whole trouble is to make bacteria not accustomed to the stress conditions, to not prepare themselves and use normal life, let's say, because they accustom and stop producing hydrogen and start methane. So all play with bacteria is to continue process to make this bacteria a little bit stressed all the time, because under the stress the bacteria produce hydrogen. The whole case is this to make this stressing possible to industrial scale, because the all trouble is to change this bacterial layer. So put bacteria and exchange. So how to change the bacterial layer so much that there is new bacteria and not stopping process. And other trouble is to produce them in so big area, because to make it affordable, they need quite much area. Therefore, we need to change to heat, for example, heat shock, which is most suitable, most commonly used due to uh, quite facile and design that allows to change this heat shock value, heat shock time, and therefore can easily be manipulated bacteria and cannot them adjust to the conditions. Therefore, this is the most often used now pretreatment. There are some attempts to use aeration or a mix of the stresses, but a mix of stresses can make difficulties the due to the device to engineering how to pre-design many types in one vessel of pretreatment. Therefore, usually it's heat shock. Other type is that very low is efficient, but they can utilize much of waste. So companies that needs to utilize waste, much organic waste in quite much volume, starts to producing and to use, because they are according to law, they need to utilize in safety, and they have some gratification. Therefore, someone who produces sugar, for example, sugar companies or juice, likes to use it. This hydrogen used twice, or for hydrogen to replace some energy, or to help the another process stage that produces methane, because of pyrolysis, because both pyrolysis and methane production, if you add some hydrogen, it's shifting to the products, and therefore the reactants are going better. So better efficiency, because if we put in a methane production, so organic waste, with acetic some hydrogen, we put some substrate for this reaction, so it's better conversion of the produce to methane. Another case is that we can use this hydrogen to pyrolysis. Pyrolysis is the combustion of some waste of materials by mean of heat or energy. This can be by oven by heat, this come or by microwave. If we add some hydrogen, also it helps. However, due to pyrolysis, you need to know that fermentation produces some hydrogen sulfide, which is quite corrosive. So, if you put this to pyrolysis, this could be more corrosive material, and therefore we need to separate, which is not very cheap. Therefore, it's more likely to produce in methane production. It was the hydrogen sulfide is so corrosive material that can even provide even destroy of plant. This is the trouble, because there is experimental plant in some Poland, but it's experimental plant uses like fermentation to promote to manage parallelism of wealth. It was tannery industry in near the Bolesławiec. Then this industry was unfortunately come to fire because hydrogen sulfide is very corrosive. So the pipes that going to this pyrolysis plant come and were corroded. So this made the fire, and fire was so big that destroyed all plant. So we need to be very careful in dark fermentation because it's useful, but we need to provide to the system that this hydrogen sulfide will not we separate, because during this hydrogen production, beside hydrogen, we have production of hydrogen sulfide simultaneously, because this bacteria during this dark fermentation they eat this spowage bacteria rest, and the result of this digestion is forming hydrogen sulfide. So hydrogen sulfide and hydrogen production needs to be overcome this problem, because we need to give the process that will not hydrogen sulfide be very harmful, and not to the vessels which are coming. Therefore, we use this in some mainly material to upgrade methane production nowadays, because it helps. It utilizes quite much more ways than only methane production, and then it can upgrade this, so methane production will be higher, so to the level that we can use in synthesis this methane. Because earlier, without upgrading with dark fermentation, methane production was good for methane as gas for household, but for synthesis of other materials, of chemicals, it was too slow. So, because it was too low percentage of gas, and hydrogen upgrading, so adding some hydrogen from dark fermentation, solved this situation. So the company that uses dark fermentation can improve the methane production from organic waste to such case that can be this methane used in industry for synthesis. Thank you very much.